Hi, Thomas.
Hello.
So I'll just be helping to facilitate and whatnot. So I'll just be here in case you have any issues. But other than that, I'm just gonna be listening along with everyone else.
No problem. Can you just make sure everyone gets in? Everyone seems to need to be admitted, so
Oh, okay. Let's see.
I don't know. I think I will get the pop-ups for that, but well, I'm going. If you could click the admits for those, that'd be great.
Yes, I can definitely do that as they come in.
Thank you.
Weekend, no. He said, this is the weekend, you're now getting double.
we'll just give everyone another minute, just in case people are trickling late from another one of the presentations. And then we'll get started. So I have in the chat, I'll post it again, a link to a website that has all of the content for this presentation. I recommend opening that up and following through as I go along. You'll be able to pretty easily copy and paste code directly from the website into the console in our studio. You don't really need to open any files as long as you have an internet connection, which if you're on this MS Teams call, I hope you do. You should just be able to copy and paste code in and have it run. So if you are able to, I really strongly recommend copying that code in, following along as we go through the workshop. Just so you can see it actually happen on your screen. But this will also be here afterwards, so if you take a note of the URL, you can navigate back afterwards. Most of the material that I'll go through is also documented in the website, so you can hold on to this, and even if you don't use this right now, you can use it later on if you find another project that might be good with this. So I think we'll get started, and people can trickle in as they're coming. So just share my screen. Bring it all back up. So I should say for questions, I will monitor the chat as we're going. I'll try to save most questions for the end, especially because we are last presentation. We can go a little longer, I think. People do really want their questions answered, but feel free to put questions in, and if it is something I think is something we should discuss right at that time, I'll answer it as we're going as well. But otherwise, we'll hold questions for the end. So, okay, let's get started. So, hello everyone, my name's Thomas Wood. I'm an analyst at StatCan. And today we're going to be talking about displaying data with our Shiny dashboard. So a little bit first at the start, what is Shiny? So Shiny is a framework within R that allows you to really easily build interactive web apps. So today we're just going to talk about really basic examples where we have tables and plots that have some interactivity where a user can do things like filter the data in a plot or filter a table. But you can do a whole bunch of more complicated things. For an example, when I was in school, I built a Shiny app that used some of the research I did for my master's project. And instead of handing a client a report with a bunch of regression tables in it with coefficients, I built a regression table that would let the user actually create some new data and then have the model predict on that data for them, and they could see the actual results of the predictions and not just look at, this variable has this coefficient and this variable has this coefficient. Actually get predictions out at the end. So you can do anything from just showing simple little plots to deploying machine learning models. Anything in between and beyond. Is capable with Shiny. Anything you can do in R, you can do with Shiny, but make it interactive in a web app. So it's a really powerful tool. We're only going to be covering very basic applications of it today, but we do have further resources that you can check out. If this is something you're interested in, you can go, go wild with it and build your own apps and do all sorts of cool things with it. So we'll just get started. So first thing we'll talk about is just creating Shiny apps. So if I pull up my RStudio. So whenever you open up R, if you want to create a Shiny web app, there's two options. One that you shouldn't do is go into New File and Shiny Web App. What you should do instead is go into New Project. And it'll just take a second. It's always the slowest when you're sharing. And then create a new directory, and then select the project type as a Shiny web application, and then give your directory a name, and then we'll open that up in a new session. And I'll show you in a second why you always want to do this using the final app that we'll talk about. But when you do create a new Shiny app, you'll always get this app.r file by default, which will always contain a little Shiny app in it as an example. You can always run your Shiny apps by up here, just pressing on the Run Shiny App button, and it'll execute it, launch a browser for you. And here's this basic little Shiny app that we have that just has this histogram, and we can control how many bins the histogram has. Notice that R is running constantly, so it's not stopped. That's because it's still hosting that website. So your R session now is essentially acting as a server for that. If you want to regain control of your session, you need to make sure you press this stop button here, and then you could do some more modifications. While this is still being hosted, your R session will be busy and you can't do anything else. So notice that we'll also have created a new directory because we created a project, and that will be our working directory. So everything is now relative to here. If you want to go on and share your apps, which we'll talk a little bit more in the future, everything you need for your app to run needs to be contained within this directory so that when you push it to a server to have it be hosted somewhere online, the server is able to access everything. It either needs to be packaged up in the same directory or available somewhere, on a URL that you can access from that server as well. And I mentioned that we should always create a new project instead of opening a file. And the reason for that is, if we look here, I've got two sessions of our studio open, both with the same app.r file, the same app, all the same information. But in this one, I've just opened the file, so you can see my working directory is just my documents folder. And in this one, I've opened it up as a project. You can see it's open as a project here. You can see the project directory down here. And both of these will run the same if I click the run button. But notice that I've got this data path here that's referencing a file within this directory. So it's referencing a subdirectory, and then there's a file in there. If we open this up as a project, I'm able to run this as static code and see that file actually be read in. But if we run this as just a file, R doesn't know where that directory is. I can run this again as an app, and it'll launch and everything will work. But this is why it's really important to create your Shiny apps as a project, have it open as a project, because it allows you to interact with your code statically in the same way that it'll interact when you click the run button. Because when you click the run button, it will set the working directory to this file, so it'll all work. But for testing and building up things, you really want to have it open as a project. So that's why I stressed that. You can find those instructions here, just follow them. Again, it's important that anything that you want to package with your apps, if you have any pictures or anything like that, they have to all be contained, other data files, etc., all contained within that folder. Otherwise, you'll run into issues when you try to share it. If you haven't yet installed the packages required for this, take time now. Again, I can throw the link in the chat again for the workshop, but I recommend following along if you have RStudio installed, make things a little easier. You can also download all the code either from here, or you can check out the GitHub and then launch the project that I created just by opening up this file here, and that will launch RStudio with the project open. So we'll get started. Again, if you have any questions, feel free to throw them into the chat and we'll answer them if they're super relevant at that time or at the end. So before we get into actually playing around with some code, we've got some discussions about the high-level structure of Shiny apps. So we saw when we created that Shiny app, we got an app.r file in there, and within the app.r file, there's three major parts. So the first part of an app.r file is the UI. So this we can see is the code that we had for that application that opens up whenever we create R. And this part of code here, highlighted in yellow, is all the code that creates the UI for the application. So this code, essentially what it is doing is it's creating the web page. So this code, all of these different functions will return various pieces of HTML, and they'll build up an HTML that will be stored into this UI object and creates our web page for us. We can actually take a look at that. Might have closed the session, so that one back up. So if we open this session up with this app, so when we run this UI, we can see we get an object up here in our environment, and if we print that out, we can see that it's actually just created HTML for us. So that's all this is. It goes through everything here and creates an input and does the layout for us and creates a place to put our plot. But this is all just creating HTML for us. If you are very good at writing your own HTML, you can you don't have to use these helper functions from the Shiny package. You can write it yourself. But they're pretty easy to get to know. And if you're already familiar with R and you're not familiar with HTML, this can be very helpful. And one of the important things to know is that we're saving this as an object because every single user that opens up our web page by default is going to get the same HTML. There'll be some parts of it that the user will then be able to interact with and update, but everyone is going to get the same default UI, the HTML by default. The second part of the app to our program is the server function. So we can see everything down here. And the server function tracks user inputs and updates outputs based on those inputs. So while every user gets the same UI, like I mentioned, every user gets their own instance of the server function, or their own session, if you will. And this ensures that any changes made by one user of your app won't impact any other web pages. So if I make a change, it only impacts my session because I have my own server function. Someone else has their own, they can make all the changes they want, it won't impact mine. The last part that's required in every Shiny app is this call down here to Shiny app. And what this does is it combines our UI and our server function into an app. After calling that function, which we're doing implicitly when we press that run button, so you don't always have to actually call this, you can press the run button as well. Your session becomes essentially a web server and starts hosting the app for your local network. So then you can, well, by default, open up a browser, but you can also navigate to the URL where your web app is being hosted, and you can interact with it, test it, play around with it, and then like we mentioned, if you need to stop it, you have to actually click the stop button to return your console to actually be in an R console and to not be the server for your website. So that's the three required sections of every Shiny app. But there's also sort of other code you can include into a Shiny app in addition to those three requirements. So anything that is above this UI function, so right now we're just loading some packages, but you could also do things like loading data, creating static environment variables. Anything like that will be done once when your app launches. And then after your app launches, all that's happening is that we're just waiting for inputs for our user, and we'll be working inside of our server. So if you need to load in some data or create some environment variables, you can do that. You just can't change those once they've been created. They'll be loaded at the start once, and then you can access them from within your server, but you can't modify them and reassign them back. So we'll see some examples of doing more than just loading libraries later on with that. So here's a very high-level overview of what a Shiny app is doing, just so that we can sort of have this sort of conceptualized in our head so we know what's happening before we actually go in and build it ourselves. So here's that example Shiny app that we saw. So it's got this nice input over here, which controls the number of bins in this histogram over here. And what this Shiny app really is a series of inputs. So inside of our code, we have some code that creates an input. So again, these are creating HTML for us. So this slider input is coming from the slider input function. We're giving it an ID so we can reference it. And then we have a label, which we can see. We're setting the min value. We're setting the max value. We're setting a default value. And then we're also inside of our UI creating a plot output. It's important to know that the space is what's being created here. So we're creating space for our plot to be put, but the actual plot itself is created inside of the server. And we know that because it has to be updatable. So anything that's inside of the UI that's static, that's always going to be here. So like this slider, we can change how it, what value we have selected with it, but that slider is always going to be there. So that's why it's in the UI. Remember, things in the UI are static. Everyone gets them. Values that come from the server are what's changing. So we can change this plot. So it's got to come from our server. So this plot output just creates the space in our UI where we'll put that. And then we can see here, we can also read and write values to our web page so we can read from this input object. So if you're familiar with lists in R, this is a very similar syntax where we have the input object, $, and then the ID of the input, which allows us to index into it. We'll talk more about this later. And then we have another object, which is the output object, and then we can index into it. And we can use this to write objects from our server back to the web page. So in this case, we use this plot, displot output to write from the server onto the web page so our user can actually see. So this is what actually is going on when we have an app. So we've got our app, it's in a steady state, we've just launched, our server is executed once based on the default value, has returned a plot, and now it's just waiting for a user to interact with it. So say the user drags this slider put over to 44 now. Immediately, we'll now update the value in our input object. So we'll say that the bins value is now 44 instead of being 30. And our server is constantly looking out at the input object for changes. So it'll see, oh, hey, our bins input has changed. It's now 44. And once it's noticed that there's a change, our server will rerun any code that references that input. So our server is keeping track. It says this input has changed. I know that this histogram depends on that input. I need to rerun this histogram. So it'll re-execute the code with the new value it's taken from this slider, generate the new histogram, and then it'll send that out to the web page by writing it to our output object. So it'll take our plot, convert it to some HTML so that we can actually display it, and then write it out to the output object. And then our web page will refresh the output object. And now we see this new plot that instead of having 30 bins, has 44 bins. And our app will once again re-enter steady state, waiting for our user to make some updates. And then we'll have that same process trigger again. The server will notice the update, the input has changed. We'll re-execute some code, we'll render that into HTML and write it to the output object, and the web page will refresh. So that's sort of a very high level overview of what's going to happen. So now we can start moving through and see how we can do this ourselves and make some more interesting apps than just this basic one. So we've talked about this sort of idea that Shiny is, got a server that's waiting for users to make input changes in our web page, and then it'll re-execute code. So this is this idea of reactivity. So Shiny is all about making it easy to wire up inputs from our web page, allowing you to access them in R, in a function that creates an object, creates some sort of result, and then have your results of your R code be easily written back to your web page. So some of the nice things about the Shiny framework is that you can change an input at any time, and the outputs that are impacted will be updated immediately. Shiny tracks all these dependencies for you, so we don't need to ever tell or write an observer. You can, if you want to later on, you can write your own observers, but for simple things like this, you don't need to create observers or anything like that. Shiny just knows, okay, this code is connected to this input. When this input changes, I need to re-execute this code. And you don't have to write any of that code yourself. And then it also makes it very easy to access inputs and write out outputs just using that simple list-like syntax, where it's input $, the ID for accessing inputs in your server. And then for writing out to the outputs, it's output $, output ID. We'll talk more about that later. So again, just to shout out that you can copy and paste pretty much all this code directly into a console and run it. So just make sure we have the required packages installed. So you can just click the clipboard to copy it and just paste it into your console and it'll run. So here is a very basic skeleton. So it's even more basic than the skeleton that you get in the default app. It's stripped away pretty much everything. And all we have within it are a couple main functions within our UI. So in our UI, everything is going to be wrapped up in this fluid page. So this creates our web page for us. It'll just be sort of a blank white space. You could write your own HTML, put it in there, but we're going to use a couple helper functions to structure our app for us. So we are first going to add a title. So this will be a little title across the top, tell the user what the app's about. And then we're going to split our web page into 2 panels using this sidebar layout function. And what this sidebar layout function will do is create a little sidebar and we'll create a bigger main panel. So we can see inside of there, we've got 2 other functions. We've got the sidebar panel. Typically inside the sidebar panel is where I would put inputs. And then you've got a second main panel, which is typically where I would put outputs. And then underneath that, we've got this server function. So this is where we'll be doing all the interactive updating of our app. So we would put our server code in here. We'll talk about that a little later. And then again, we're always going to finish this off with a call to Shiny apps. So if we open up our console, we can just paste that code in. So we've just copied and pasted the whole thing in. And as long as you have Shiny installed, you should just be able to hit enter and it'll run. And we'll launch a little app. So this app, as I mentioned, right now it's just a skeleton, doesn't have anything in it, but we would have our title up here, we filled it in. You can see this little box here is the sidebar. As we fill in content, it'll expand out. And this big white space over here is where our main panel is. And one of the things, so we used a fluid page. So one of the things that we'll do is now our main panel will reflow down here if we don't have enough width. So Shiny will take care of any reflow into content. So it makes it pretty easy to make stuff that will also work pretty well with mobile just by default. So again, close that, but we have to make sure we stop our console from running in order to gain control again. So a fluid page with a sidebar layout is a pretty good option for building a Shiny app. There are other skeletons, other templates that people have that you can use. I really like fluid page. You can do other styling with CSS and stuff like that if you want to make it just look like something other than just a big white screen. But again, fluid page will reflow content if there isn't enough horizontal space. And sidebar layout is really good because it creates two defined areas where your user can look, with the sidebar typically having inputs and the main panel having outputs. You can also use functions like fluid row and column to further organize your app. But we're not going to talk about that too much today because the sidebar layout and the fluid page does a pretty good job of laying things out for us. So before we get into the really interesting stuff, we'll talk about how to add some static elements to UIs. This is not the real reason to use Shiny. If you want to build static websites, there's easier ways to do that. In R, you could use R Markdown. There still are times where you want to add static things to an app. So, for example, common tags from HTML are available as functions. So these are little helper functions. So, for example, div tags has a little function, h1 has a function, a, br, they all have their own functions. But things that are less common, you can find inside the tags object. So, for example, if you want to use an abbreviation, you can use the abbreviation tag. You take the tags object, index into it with the $, and then it'll give you all the different abbreviations, big caption. There's all sorts of ones you can want. So here we can see the skeleton app again. It's always a good idea to start with a skeleton and then fill it in as you're going. So we can see we're adding a title. So this will be a first level heading because it's going to be a title. Then we can use this h2 function where we're passing a string into it. We can also just have normal text. We have another h2. We have a paragraph div with some bolded text inside of it. And also notice that everything inside of our UI function is joined with commas. So we've got this fluid page, which creates the whole space. And then next to that, we've got the title panel, then we have a comma, then we have our sidebar layout. Inside of our sidebar layout, we have the main panel, which has some things passed as arguments to it that are all joined with commas. At the end of the sidebar layout, the sidebar panel, we have a comma before the main panel. Everything has to have commas inside of our UI. It's very important, and it's different than in our server, which we'll see in a little bit, where we don't want to use any of these commas. But all of these different things we're adding, they're all arguments to these other functions. So they, just like any other time where we have multiple arguments in a function, we have to join them with commas. And then notice for this, we don't have anything inside of our server yet, because all of this is just going to be rendered out as HTML and will be displayed to our user no matter what. So we can again copy all this code into our console, hit enter to run it, and immediately we get a little pop-up, and here we can see our title, we can see the text we've got inside of our sidebar, we can see the text that we've got inside of our main panel, we can see the bolding, and we can see that reflowing that I talked about earlier, where when you have a narrower window, that main panel reflows down to the next row, so we don't have to worry about content going off the side. So fluid pages, good option for laying things out. Not the only one, but good. And remember, we're always going to stop console after we've done that. So like I mentioned, notice that we have to have, everything has to have a comma. And we don't have a lot of time, so we're not going to be able to talk about adding other static elements, but there's a really good tutorial here where you can see things, for example, how to add images, how to do more fancy things with text, aligning it and stuff like that. So if you are interested, check that out, because in addition to our interactive outputs, you might want to include things like headers and titles and maybe some descriptions to explain to your user how exactly your app works, some interesting things about the plots, stuff like that. So that would all be static content. So you could add it using information you find here. So now we're going to talk about building our app around inputs and outputs. So up until now, everything we've seen has been simple, self-contained, mostly static, and pretty much has exclusively been created in the UI. But that's not what Shiny is about. Shiny is about making things interactive. If you just want a static website, go check out R Markdown. It's great. It's what the website for this material is written in. But it's static. If we want to do things that are interactive, that's why we're making the Shiny app. So we make things interactive in Shiny by adding inputs and outputs. So we're going to go through some different examples of inputs to start, and then we'll move on to outputs. So inputs are created using a function that typically follows the format of the input type, and then input, and then our brackets like any other function. And what they do is they create HTML for our app, and then they send their values back to the server. So like we saw earlier when we printed out the UI object, everything that goes into the UI object creates HTML. That's what we're doing. It's creating HTML, and then that HTML gets rendered by our web page so that our users can see it and interact with it. So all of these functions are going to go into our UI. None of these go into the server. They're all in the UI. So we've got things like action button, which gives a button in a web page and allows you to collect whether or not that button's been pressed. Checkbox inputs, which creates a checkbox and lets you collect whether or not that box is checked, which is a true, or unchecked, which is a false. Group checkboxes, which allow you to track the state of a group of checkboxes. You get a vector of which boxes have been checked. Date inputs to collect a single date. Date ranges to collect a vector of the min and max date for that range. File inputs, if you want to allow your user to upload a file to your app, maybe to allow them to make their own plot, for example. Numeric inputs, which allow you to enter a value, a numeric value. Password inputs, which allow you to enter passwords. Radio buttons, which allow you to keep track of a set of exclusive options, so you can't, unlike the group checkbox where you can pick multiple radio buttons, it's a single choice for multiple options. And this will tell you which choice was selected. Select inputs allow you to create a drop-down where you can either select a single value or you can select multiple values. And you'll either get a vector of length 1 or a vector of length n out from that. Slider input, which we've already seen, which allows you to have a single number, date, time, or a range of those. So you either get a single value out or a vector of the min and max values. And then text inputs, which allow the user to enter text. And these are just what comes by default with Shiny, but there's other inputs that you can get from other packages that allow you to do other things. If you want to get like a dial or something like that, people have created all sorts of different inputs that you can access through Shiny. Or again, you can write your own HTML. So the syntax for inputs is always going to be our function, and then every single input is always going to require at least 2 arguments. They're all going to require an input ID, which must be a string, must be unique, and cannot use special characters other than underscores. So these are used to create the IDs for our inputs, and they are how we access our inputs inside the server as well. And that's why it's important that they need to be unique, because if you have 2 inputs with the same ID, how will the server know which input it should be reading from? Can't. And same thing goes for the special characters. If you use things other than underscores, that can cause misform HTML. So it has to be no special characters, nothing other than underscores and letters. And they all will also require a label. And the label describes to your user what the input is for. So this can be a little bit more open-ended. You can use anything inside this string that you want. But all inputs are going to require at least those 2. These ... dots here means that there can be other options that you need to pass on to inputs. So for example, we can see down here for a checkbox input, it requires also that we supply it with a value, which in the context of checkbox is whether or not the checkbox is checked or unchecked. So by default, this checkbox will be checked. Other options, such as choices, are often, that's the other common option that you need to supply. So for this case, with the group checkbox, we need to give it the choices so we know what checkboxes we're actually creating. Same thing with radio buttons. We need choices, drop downs, we need choices, numeric values. Sliders require a min, a max, and a value. But otherwise, you can always see that they're all going to require an ID, an ID, an ID, and a label, and a label, and a label. And that these can't have any special characters, can't have spaces, dashes, nothing, just underscores and letters, whereas the labels can be more expansive. So we can take a look at this. Notice right now we don't have anything inside our server because these inputs aren't actually connected to anything, but that's okay because by default, they don't need to be connected to anything. They can just be inside of our app, and we've got, so they were all put into our sidebar, up the sidebar layout. I like that. You can put them in the main panel too. There's nothing that stops you from doing that, but sidebar is a good place to put them so the user knows, okay, these are the different inputs. So you've got action buttons that you can click, checkboxes, group checkboxes, date ranges, date inputs, file inputs allow you to load files, numbers, passwords, radio buttons that are exclusive, drop downs. In this case, it only allows a single value, but you can allow multiple values to be selected from a drop down. And this is a single value slider, so it just takes one value, but you can also have multiple value sliders where there's a min and a max. So again, we'll always make sure we stop our app after using it. So we can see inside of our sidebar layout, we have our sidebar panel, and then everything that was our inputs is going to be inside those matching brackets here. So they're all going to be inside of our sidebar layout, and we don't have anything down here inside of our main panel. So now we've got outputs. So outputs, similar to inputs, are always going to be created with a type output function. And an output is comprised of two parts. So we're first going to talk about the the first part, which is the space in the UI for the output. So we saw in our first example app where in our main panel we had a plot. I mentioned that that plot isn't actually created inside of the UI, it's created in the server. But we have to have a space inside of our UI so that the server knows where to put that plot. So these functions here are all going to be those, and then we'll talk a little bit later about the code that actually goes into the server to create the output and render it into HTML so that we can display it. So these are all going to be UI functions. So just like the inputs, all of these functions only go into the UI. They don't go into the server. And it's also important to know that we have to build these separately, and it's not an error to put a space into your UI and then never put something into your server that's connected to that space, and vice versa. You can have server code that doesn't have any function on the UI. You can have UI that doesn't have any server code. It's not going to tell you. And this is why it's very important you're keeping track of your output IDs and that you're spelling them correctly. Again, they have to be unique. We'll talk about that in a second. But just know that you have to build these separately, and it's not going to throw an error if you don't build them separately. So the syntax. So outputs typically only require one argument. They'll have other options, for example, heights and stuff like that. But typically, all outputs are going to require is an output ID. And we'll talk about when we see the server a little bit more what exactly this output ID is. But essentially, it's going to connect your server to the space in your UI wherever you want to write that output to. So it's saying this is the place to put that result. So just like the input, saying this is where I want to read the value from, the output ID is where you want to write the value to. And we'll see that a little bit more when we look at the server. So just like an input ID, output IDs must be strings, must be unique, and can't use special characters other than underscores. Again, we can't have multiple places that we're writing our outputs to, so the server doesn't know which one it should write to. So it has to be unique, and it can't have any special characters because it'll cause malformations in the HTML. So very important. And these IDs are what is going to link our UI with the HTML that we create in our server to actually display things. So here we can see, I didn't go over specifically, but there's a lot of different outputs. We have a bunch here, but there's actually more that you can get. So for example, pulled up, so anyone that was in the leaflet presentation earlier, you can also, with leaflet, you can add those to Shiny apps. So you can see a leaflet output here, and it's got its ID. And then we'll talk a little bit more in a little bit about rendering, but you can see there's a rendering function for leaflet as well. So if you have other third-party apps that you want to use as well, oftentimes, especially very popular ones, will have built-in functions that will allow you to use them in Shiny. But these are all the outputs that are available by default with the Shiny package. So we've got a data table output, which creates an interactive table for you. This allows users to filter and search within the table. You can have table inputs, which will render a static table, image outputs, plot outputs, which both sort of have either image or a plot output to them. Text outputs and verbatim text outputs both render text. We'll see when we look at the demonstration what's the difference, just the styling of them. UI outputs, so sometimes you won't always have all the information right at the start of your app to fill in all your UI. So remember, UI is static. Whatever's in the HTML is just given to a user. A thing needs to be updated. It has to be done on the server. So for example, we saw there's a file input. If you wanted to allow a user to load a file and then select a variable from that file to plot, you couldn't anticipate what values to put in that select, in a select input to allow the user to pick up a variable, because their file could have whatever variables. So you would need to wait for that input of the file, and then you could use the names of those variables in the file to create a dropdown that would allow the user to change. We're not going to talk a lot about using UI outputs, but just know, if you do have something that isn't static at the start, but requires some input from the user first, you can use the UI input to render things afterwards. And then we also have HTML outputs, which just will display raw HTML. So here we can see an example, so we can copy that. And notice right now I've got nothing in the sidebar. If we don't have any inputs, everything is inside of our main panel. And we've got a data table, etc. And they all have their IDs, that's all they require. And also notice that I have filled in some information into the server. We'll talk about this in a little bit. But otherwise, this would be a very boring app because, as I mentioned, by default, these don't actually do anything. They just create space for your server to save something in to update the app. So if we want to see something, we have to supply. But we'll talk a little bit more in a second about what exactly is happening in the server for us to be able to see. So we copied our code. We can paste it into the console, hit enter to run it, and we'll get a nice little app. And here we can see, again, in our sidebar, we don't have anything, but we can see we've got all these different inputs. So right now we've got this data table input here where you can search within it, etc. You can do filterings and stuff like that on the different variables. You can arrange stuff. It's all paged. Underneath that, you've got a static table. So this just renders out as an HTML table. So you can see the whole data set. Then we've got this plot. Then we've got this rendered text. So this is a text output. And then we can see underneath it is a verbatim text output. And the difference is just that verbatim text outputs have this little box that they're styled with. And finally, we can see a piece of rendered UI. So this is not static UI. In this case, we're not doing anything interesting with it, but this was UI that was created inside the server. And once the server returned a result, then it was added. So it's not static. It's not always here by default. It's created in our server. So this would be the example where we could put, replace these values with variable names or something like that that's coming from a user. And when we close that, we always have to make sure we're stopping our session so that we can get it back. So some things to notice is that every single one of our outputs that we have has to have a corresponding entry into the server. And they're always going to be tracked using those IDs. So we can see this data table output has its entry here in the server. Table output, plot output, verbatim or text output, verbatim text output, UI, etc. And they all match in here. Also notice that unlike in the UI, these are not joined with commas. So these are all their own separate expressions just contained within inside the server function, but they're not arguments to it. So they're not joined with commas. They're just their own separate block that's saving into this output. And that's all we have. We have these input and these output. We're going to read values from the input, and we're going to write values out to the output. And also notice that it's important that whatever we have inside of these curly braces, that's actually what's going to be rendered. And that will depend on what type of output we have. So for a data table output or a table output, we need to have a table or something that's similar to a table, like a matrix. So for example, iris here is a table, but if we have a plot output and we're rendering a plot, we need to have a plot there. So we're using the base R plotting libraries, but you can also use ggplot, for example. But what's important is this returns a plot. Text outputs need to return text. UIs need to return UI. So that's, it can do other things. We'll see some examples later on. You don't just have to have just a table by itself. You can do other things. You can filter it, select, mutate it, however you want, but it needs to return at the end a table or a plot or text or a UI element. So each output in the server is saved into this output object, and we'll talk a little bit more on that in a bit. And it's always going to follow the same syntax where we always have the output object, and then we index into it with the $sign operator with our ID. And that tells us where into the output object we're going to save things, and has a corresponding entry in the UI for each of those IDs as well. That's where we're actually going to put those results after we create them. And we'll talk more about why there's different rendering functions in a second. So after creating a place in the UI for the output, you need to write the actual code to create that output. Outputs always have to be saved into the output object. So it's always going to look like this. Always going to have output, our output ID, assignment operator, and then some code that creates our output, so a table, etc. So if we have in our UI a plot output and a table output called plot and table, then in our server, we have to have an entry for output $plot and an entry for output $table. So in order to actually display these different objects, because how does a web page, it has no idea how to display a data frame or display a ggplot. That's not what web pages do. They display HTML with JavaScript and stuff like that. They don't display our specific data types. So in order to actually show those on the web page, we need to render them and convert them into HTML that the web page can actually display. And that's why we've got all these different rendering functions. And rendering functions, just like output functions, are dependent on what type of data you have, and they're going to typically be matched. So for a data table output, you have a render data table. For a table output, you have a render table. For a plot output, you have a render plot. For both a text output and a verbatim text output, you can use render text. And for a UI output, you have render UI. And if we look again at that leaflet example, we can see the third party will have its own renderer. So it's got its own output object, and it's got a matching rendering function for that. And we can see here, this is that code that would return a leaflet. And you can see it follow through all the way to the end of the chain. This will return a leaflet, and then we render that into HTML that can then be displayed in our web page. So here we can see some examples of a server that has some renderers returning results. So we can see we've got our plot output, and into that we're saving the results of this render plot. And then everything inside of these curly braces has to be our plot code. So you can do other things inside of here, but it has to, at the end, return a plot. Same thing with render data table. Everything inside of these curly braces needs to return a table at the end. So in this case, we're just returning a static table. And we could do the same thing here. This would return a static table using the render table function. But notice that I have to have it commented out right now because we can't have two places in our server writing to the output table space, because the server needs to know, am I showing this or am I showing this? So we could, as long as we swapped the output object inside of our UI as well, change this to just a static table, but we can't have both elements inside of our server at once. It needs to be one or the other. So that's pretty cool. So we saw those inputs, we saw those outputs. We could play around with the inputs, we could see the outputs. But we couldn't actually interact with those outputs because we looked at this example here. This is just going to return this table. This is just going to return this table. This is just going to return this plot. This is just going to return this text, and this UI. We're not actually adding anything into those that are interactive. But that's why we're making a Shiny app, is to be interactive. So we do that by connecting our outputs to one or more input. And the simplest way we can do this is by filtering, but you can also do other things like supplying the value of an input as a parameter to a function, and you can get more complicated from there. We're just going to talk about those two examples today. But there's other ways you can build reactivity using inputs. This lets us take static data, so like our iris data set that we've seen a couple times, and we can turn it into reactive data, which reacts to the different inputs we have and then can drive the outputs in our app. So now we can see this slightly more complicated app, and this is going to have two inputs. It's going to have a slider input that's called n and has a label called number and has its defaults for us. And then we're going to have a select input, which is called species and it's labeled species. And then we have to supply some options. So notice that we're going to let the user select multiple. So unlike the previous examples we've seen with the drop-downs, users can pick multiple values from this. So we have to give them the choices. In this case, we're going to read those choices from the species variable in the iris data table. Instead of supplying these ourselves, we could write them out as a vector, but this is a little easier because we already have them in a vector. So we just take those unique values. So this will get rid of any duplicates. And because we're taking multiple values, we have to filter, we have to tell it which ones we want to select. So in this case, we're going to select everything by default, but the default behavior, if you're having multiple options, is to select none of them. If you have one option, if you can only choose one option, it'll default to selecting the first one. So because we're doing multiples and we want things to be selected by default, we have to tell it we want those ones. And then we have one output inside of our main panel, which is called table. And then inside of our server, we can see into the output object at table, we're going to assign the results of render table, and then everything inside the curly braces is what we're going to be doing. So we're going to take that original iris table, and we're going to pipe it down to a filter, and we're going to filter the species variable inside of our table so that it is in the vector returned by input species. So this will be the values we've selected in our dropdown. And notice that we have to use the in operator here because theoretically this can be one value, two values, or three values. It could be a multiple length vector. So we need to use the in operator. We can't check for quality with a double equal sign. And then we're also going to use the n input down here as an argument to the head function, which will determine how many rows of the table we're going to display. So just like always, we can copy our code, open up our console, paste into our console, hit enter to run, and we'll get a lovely little app that has a slider, has a select, and we can see here that we can choose multiple. So by default, we picked everything, but if we only want to pick one of them, we can choose which ones we want. So maybe we just want Setosa. And then we see up here, we connected this to the number of rows. So right now we've got 10 rows, but maybe we just want one row, or we want 100 rows. This is connected to this value. So every time we change this, the server sees, okay, the n value has changed. This table depends on that. I need to re-execute this code. Every time we change the values here, the server sees that the table depends on this input. We'll re-update this table. It's sorted by species, so you can't actually see it very well. As we change those and delete them, it will update the table as well. And again, closing the web browser is not enough. We have to make sure we actually stop serving the web page by pressing the stop sign. So now we've seen a little bit more complicated of an app. That's great. Just got a little side note about deploying your app. So you can just share your app like this. If you don't require any other files or something like that, you can just give the code to someone else. And so long as they have R and the required packages, they can just run your code. That's great. You can also share those files with them. And that's fine if you just want to run it locally. But typically we want to have these at least somewhat public. So you can run your own Shiny server that will do all this hosting for you, but you don't need to do that. RStudio provides a service called shinyapps.io, which has free hosting for a limited number of apps for a certain number of hours, I think 25 hours a month. We're not going to talk about actually how to deploy your apps to shinyapps.io. It's very simple, but just outside the time frame that we have. But you can look at this article here, how to set it up. It's very easy, and once you do, you can just navigate to a little URL. This is a Shiny app that I have hosted. So you can just, and this is all just that same sidebar layout, just themed with CSS, and you can host your own Shiny apps. So one thing, though, that is important to mention before you publish anything, it's not a super big issue if it's not important data. That's probably the worst thing that can happen is like someone makes you lose all your data that's in this Shiny app. But it is important to consider security whenever you're publishing any kind of web app that allows people to interact with the server. Fortunately, if you use something like shinyapps.io, they'll protect you against someone maliciously using your server to mine Bitcoin or something like that. So they take responsibility for making sure no one's using too many resources or that no one else's app can access your app and stuff like that. But there is still things you need to do within your app to make sure that it's safe. So before you publish anything, I recommend checking out this chapter of Mastering Shiny that just goes over some of the things you need to consider, such as validating inputs inside the server, because users can modify inputs through JavaScript inside the client, inside the web browser. So you have to actually validate it inside the R server if you want to make sure that no one's doing something funny with your inputs. Or, for example, accidentally letting people execute arbitrary code, or how to properly escape SQL, so that someone can't make their username in a database, some SQL that actually deletes all the tables from your database. So simple sort of things that you sort of always have to think about whenever you're developing a web app, but you can see some examples specifically how to avoid those common errors and common issues within apps in this chapter. So it's a quick read, but check it out before you publish anything that is more complicated than what we're talking about today, where we just have a simple file and a couple tables. Okay, so that's the main theory. So now we can talk a little bit about a more complicated example. So if you've cloned the repo up above, you can open up that project file and just run this, and that will launch the app. You can also check out the source code for the app here. But for people that haven't, I've also included a version that you can run just by copying and pasting it here. Notice that because I'm not sharing the actual file, if you're just copying and pasting this, we need to have our data file be somewhere that's accessible. So it's hosted, in this case, if you're copying and pasting this, on GitHub. Whereas if you open up the file from the project directory, it'll use this data path instead and run from the local version of the file, because it has to be somewhere that it can be contained. And because my setup, I'm going to use this one, but you can copy and paste this and it'll just run from the version that's on the GitHub. So we can see some things here. So we've got this code here at the start, and all this is we're going to read in some files. So we got our data, we're going to read it in, do some cleaning, get some things, make things into factors so that they display nicely in plots, create a couple of static variables that we're going to use instead of rerunning these functions a couple times. And remember that anything that's at the start of a Shiny app, so all this stuff will only execute once. So when we launch the app, it'll run never again. Then we can see our UI. So we have a fluid page, which is going to have our title, and we're going to have a sidebar layout. And inside of our sidebar, we're going to have a couple inputs. So we're going to have this slider input for the years. So it'll be a min and a max value. So we've got our min year and our max year from our data, and the user can pick anything between those. Then we've got a select input that has multiple choices, and we can pick occupational categories for R&D personnel. It defaults to selecting, so these are the options, and that defaults to selecting everything. Then we're going to have a select input for country of control. So that's our ID and our label, and it's going to have all the different values, the unique values from our data. And then we're going to have this NAICS variable, which is an industry classification, and again, all the values from our data. So this unique data frame $sign variable name, it's very useful for this. Instead of having to, there's 70-something options in this variable. You don't want to write out 70 options by yourself. So it's nice to have them stored in a table that we're reading in. So this is coming from a CSV. We read it in, and then we can just reference those values from their vectors in the table instead of actually having to mess around with them. And then we've got our main panel, and that's going to have two things in it. It's going to have this plot. And notice that in addition to its ID, I also provided a height option, just because I think the default height is kind of small for a plot. We're going to add a static horizontal line to just divide up the area, and then we're going to have a data table at the bottom. And then driving all that, we have our server, and we can see we've got one entry here for our plot, and that's going to render a plot. And then inside the curly braces, we're going to start with our data. And then to make it interactive, we have this filter. So we're going to do filter to say that our reference date is between, and here we're going to reference the values from these inputs. So the input year, and these will be the min and the max values. So as the user changes the slider, that will update and will change which data passes this filter. And then country of control, same thing, because we're taking a single value, we can check for equality with this input. So as the user changes this, that will change this filter. Same thing with NAICS, takes from the NAICS input. As the user changes that, it'll change what passes this filter. And then because we have multiple values that can come for all occupational category, again, we have to use that in operator because this could be one value, it could be 5 values. So we have to use the in to check that these values are in this vector here. But then after that, after we've done this filtering, which is the interactive part, all we're doing is just passing it to some very standard ggplot code. So this doesn't have to be ggplot, could be base R, could be anything else, but we're using ggplot because that's what I like to code plots in. And then we finish off those curly braces, and the last thing that we're getting out is that plot. So again, because we're doing a render plot, it needs to be a plot that comes out. Same thing for the output table. We're rendering a data table. We're going to do that same thing where we take our data, we pass it to a filter. It's the exact same filters where we check that the reference date is between the min and the max, that the country of control is equal, that the NAICS is equal, and that our occupational categories are inside of the category input. And then we can do some selecting and arranging and stuff like that to make the table look nice. But at the end of the day, it just needs to return a table at the end. And because we end up with a range, what's going to be returned from this is a table. And then we're finally finishing our app off with that launch the Shiny app function. So if we open this up and I go to the Shiny app, so here we can see that same code. Just notice that because I'm using the code that comes from the GitHub, I'm not connected to the internet actually on this network. I have to use the local file. I can't actually access this because that's on the internet. But I could just run the app, or I could do the functions, and we get our nice little Shiny app. So that's all interactive. We can change which years we want. So maybe we just want, actually let's just do 2019. Maybe we just want total people and total contractors. Right now it's total country control, but maybe we're only interested in Canadian businesses, and maybe we're only interested in ITC business. Let's do telecommunications, that's fine. So we can see this data up here will all render out and change as we're going through and we're adding different things. So we can see, again, as we change this to total country of control, these values will shift. The values that are in these tables down here at the bottom were also dependent on these inputs. So they will also change. But again, because things like data table outputs have their own interactivity that's built into them by default, you can take advantage of that stuff. So you can do sorting, stuff like that with this, but you also have this plot up here that also responds. So that's all I have for the main bits. The last thing is just to plug that RStudio has a great collection of other Shiny resources. So we have just scratched the very, very, very minimum surface level of this information. There's a lot more complicated things you can do with Shiny. So if you're interested, if it did spark your interest, you're not someone that is super comfortable writing a bunch of JavaScript and CSS and HTML to write your own app, web app or something like that, or you don't know another framework, Shiny is a great option because it doesn't have a very high barrier of entry, but you can scale up to very complicated things as well. So I don't see any questions in the chat. If people have any questions, I'm free to stick around for a little bit if people want to ask things, but otherwise you're free to go. I do recommend grab the link for the project on GitHub so you can come back later and check it out. A couple months later, you do think, maybe I want to check this out again. So does anyone have any questions? I'm not hearing anything, so guess that's it. So thank you, everyone.
Thanks, Thomas.